Okay, friends, here we are with part 2 of our study or preparation for our test this week. So here's section 2.4. 2.4 deals with solving equations with variables on each side, more complicated, and that'll be the duration. That'll be the entire video that we do. And so definitely pay attention. We'll do as many examples as possible to make sure that you get a full benefit. So here are some hefty examples. If these don't scare you, you're like, I can do this, that's great. Still follow along with us. If they do scare you, take your time, review the video as many times as you need to because it should make sense. We have a couple of very simple rules when solving equations with variables on both sides. And the first rule is to simplify both sides of the equation separately and then follow through with our typical solving techniques. Because we have so many example problems, I don't want to crowd the page, so I'm going to take each example one by one and give it its own page, its own due, so we can kind of take a look at it and really analyze what's going on. Our first example, 2 plus 5k equals 3k minus 6, has really nothing to simplify on either side of the equation. 2 plus 5k are two different terms. They can't be joined, nothing to do there. And 3k plus minus 6 can't be joined either. So what I'm going to do is choose a side for my k variable. I'm going to, generally most people will choose the side with the higher number of k values. And in this case, we can choose the left side. It really doesn't matter, but that's what most people would do because this way we stay away from having negative numbers. And on this side, I'm going to put C for constant terms. So all the regular looking numbers or constant terms will go on the right side of the equation in this particular example. But again, this does not have to be the case. Now that I've made a decision about where I want each thing to go, I look at first the left side, which doesn't belong. 5k is perfectly fine because it is a k term, but it's the 2 that doesn't belong. So I get rid of the 2 by adding a negative 2 to both sides of the equation. When I do that, I'm left with 5k, and the 2's cancel each other out, is equal to 3k. Now negative 6 minus 2 is going to give me a negative 8. My next step is to now honor the fact that I only want C terms on this side, or constant terms. That means the 3k's got to go. This 3k can be moved by adding a negative 3k to both sides of the equation. And when I do that, this becomes negative 2k. Just kidding. It becomes a positive 2k. And these guys cancel out, and I'm left with a negative 8. Finally, I'm going to divide both sides by 2. And when I do that, I get that k is equal to negative 4. This second example looks like a big deal, but trust me, it's not. If you take the steps one at a time, you'll feel really comfortable with it. The first thing we're going to do is simplify the left side of the equation here. And in order to do that, we need to employ the distributive property. The distributive property gives me the power to get rid of the parentheses, which is going to be great. So 6 times 5m is going to give me 30m. 6 times a negative 3 is going to be a negative 18. That's really important to make sure we write that down. And here we're going to rock a little distributive property again. Don't be afraid. Nice things happen. Each of these numbers, 24 and 12, are divisible by 3. So now I have 1/3 times 24, and that's going to simply give me 8m. 1/3 times 24m gives me 8m, and then 1/3 times 12 gives me 4. This looks like a problem that we just did. I need to choose which side I want my m terms on. Since the greater number of m terms are over here on the left, I'm going to choose this side as my m side and this side as my constant side. Now it's just a matter of moving things that don't belong. On the m side, on the left side of my equation, I recognize that this 18 has got to go. So I get rid of the 18 by adding its opposite. It's a negative 18 because of that minus sign. I add the opposite. I'm left with 30m. These guys are gone. Is equal to 8m plus 22. The next thing that I need to do is get rid of the 8m on this side because it is not a constant term. I do that by adding its opposite, and that looks like division. Let me fix that. Did that last time too. I don't like that. Okay, so I'm going to add its opposite, which is 8m, negative 8m, pardon me. When I do that, on the left side of the equation, I get a positive 22m, and on the right side, I get a positive 22. That always feels really nice. Again, I'm still trying to isolate the m term, so I'm going to divide both sides of my equation by the coefficient of m, which is 22, and m is equal to 1. We're going to continue following along with our first and most important step to simplify both sides of the equation. On the left side, 5x plus 5 cannot be simplified because 5x is the next term and 5 is a constant. But over here, the right side, so juicy, we are going to distribute our 3 to get rid of the parentheses here, and we are left with 15x minus 12, and we're going to bring down this minus 10x. I'm going to drag the left side down. Though I can't simplify it, I want to just keep it together. And what I'm going to do here is join like terms. I've got a positive 15x and a negative 10x. And when I bring those two guys together, I get a positive 5x. Leaving this side, 5x minus 12, which is equal to 5x plus 5. I'm going to just follow along and say, okay, I want my x terms on one side. I want my constants on the other. And already some of you, your spidey senses should be tingling because something just ain't right. But that's okay. Let's keep fighting and we'll talk about what's not right here. So I'm going to, since on the left side I need to have my x terms, this 5 has got to go. I'm going to add the opposite on both sides. I'm left with 5x is equal to 5x minus 17. Yes, 5x is equal to 5x minus 17. This looks crazy. I'm going to continue. I need only c terms here, and I'm going to get add a negative 5x to both sides. When I do that, I'm left with 0 is equal to negative 17. Should you be upset by this? Absolutely. There is no way that 0 could equal negative 17. Two different numbers cannot equal one another. This equation has no solution. Let's talk a little bit about this. When we have a situation where there's no solution, oftentimes you will end up at the end of solving with a lie, something that's completely not true. And then when you go back through your equation, if you take a look at the process as you were solving, you will see that there were some telltale issues. In this case, we had 5x and 5x on both sides. And then we were adding two very different numbers to that same value, and we were saying that it was equal. And clearly that's a problem. I do want you, even if you see this issue, to process to the very end so that you get this, I shouldn't call it a lie, perhaps a conflict or a falsehood. Whatever you want to call it, it ain't right, and therefore you know you have no solution. So I do want you to work out the whole problem all the way to the end until you figure out or try to solve for x and you come up with this issue down here. With example 4, we've got something interesting happening as well, so do pay attention. Check it out. We're going to do what we usually do. We'll simplify each side of the equation. We'll start off with the left side. I'm going to distribute through to get rid of my parentheses. So 3 times 2b gives me 6b. 3 times a negative 1 gives me a negative 3. And then I'm going to bring my negative 7 down. And if you look at the right side is completely simplified because we've got two different types of terms. On the left side, however, we still have a little bit more work to do. This negative 3 and this negative 7 can be joined together to give me 6b minus 10 is equal to 6b minus 10. Oh no! This is a situation where, we can continue solving. I can say, oh, I want my b terms over here and my constant terms over here, and I can keep working it out. When I do that, you already see what's happening. I shouldn't even continue, but I just can't help myself. I love it. All right, so that goes away. You're left with 6b is equal to 6b. And what? We could divide both sides by 6, but basically what you're seeing is it's like looking in the mirror. You've got the same thing on both sides. You've got no better information about b than you had when you started. All you know is 6b is equal to 6b. And you can divide both sides by 6 and say that b is equal to b. Is that helpful? No. What that means is any number would work here as long as b is equal to itself. Well, any number is equal to itself. Therefore, the answer, when you see the same thing on both sides of an equation and you've got no clarity about the variable, is that the answer to this is all real numbers. There we go. All real numbers would fit in this situation. So b is equal to any old real number. There's no singular solution. Anything goes. So those are the two strange examples, number 3 and 4. Make sure you hold on to those. You will see them again. I added this one for kicks and giggles because everyone says, oh, fractions, they're ugly, they're horrible. So I figured let's go ahead and do one just to make sure that we can handle them. Basically, we want to get rid of the denominator. That's the problem. The problem is the denominator. So we're going to look for a value that we can multiply both sides by in order to, what I say is, absorb the denominator. When the number that I'm thinking of is a number that 12 goes into evenly and 8 goes into evenly. Certainly I can multiply 12 times 8 and get a fairly large number, but I'm going to look for what we call the least common multiple. If you think hard, you'll realize that that number is 24. 12 goes into 24 evenly and 8 goes into 24 evenly. So I'm going to multiply both sides of my equation by 24. Let's try to find a nice bright color to accentuate that. Beautiful, beautiful. So if I multiply this side by 24 and that side by 24, I'm going to do a little distributive property to simplify this. So 24 times 1/12 is really 24 divided by 12, which is 2. Got to keep going. Don't stop. 24 times 3/8. Couple things going on. Divide the denominator into that number 24, then multiply the result by 3. It'll save you a little bit of time. 8 goes into 24 3 times. 3 times 3 is 9. I'm left with 9y. Okay, stop singing. The next thing we've got to do is a little bit of distributive property on this side as well. So 24 times 5 over 12. I'm going to divide the 12 into the 24, which gives me 2. 2 times 5 is 10. Again, I'm going to perform a similar operation by dividing the 8 into the 24. I get 3. 3 times 5 is going to give me 15. So I'm left with this beautiful problem that feels so much better. Let me change the y so they're a little consistent. There we go. Make everyone happy. All right, so now we're going to do what we usually do. Choose a side for the variable, choose a side for the constant, do our thing, solve the problem. Let me change back to my yellow, and let's do what we got to do. Here I'm going to choose this side for my y side and this side for my constant terms, just because there's more y's on the right than there are on the left. If the right side is where my y's will go and the left side is where my constants are, then obviously this 9y does not belong on this side. So notice I'm adding its opposite, doing what we usually do. 2 is equal to 10 plus 15 plus a negative 9 will give us a positive 6y. This is looking so simple. I'm going to get rid of the 10 over here because I only want y terms by adding the opposite. I'm getting stuck here for space. Let's see if I can fit it all. Finally, I'm left with 6y is equal to, let's see, no. Okay, I did something strange, but we were basically at this point. We have 6y is equal to negative 8 when we subtract the 10 on both sides. Let me see if I can put that in. Or add negative 10 to both sides, pardon moi. And now that we have that, we're going to just divide both sides by 6. Let me write it over here. I keep trying to accentuate a little too much. So we're going to divide both sides by 6, which is the coefficient of y, which we're still trying to isolate. That cancels out. I'm left with, and I'm very comfortable with improper fractions. I like them reduced. I'm left with negative 4 over 3, and that's my y value. Yay! I hope this was a helpful video. Please ask any questions you need to in class, and I will happily answer them. Good luck studying. Another section that you can look at in order to study is page 141, section 2-4, with lots of examples similar to these.
Made with Doodlecast Pro.